Okay, today's question, following up yesterday question, is also concerning uh, Pokemon. So the question is that if our trainer and you are a type-specific trainer, meaning that you can only choose one type of Pokemon to use during a battle. So which type is the strongest? So this is kind of a simplified question, because in reality, in the real Pokemon game, we can use a combination of types of Pokemon and different attacks, different types. We can combine and get a best performance by mixing all this type of Pokemon. So today's question is that if you can only use one type, which type will you use? So we can estimate, or we can ans respond to this question by observing and do some really simple and simplified and analysis on the dataset. As usual, we read the CS file containing the Pokemon dataset and read it and load it as a pandas data frame. And we first of all, we drop some columns or drop some attributes that we think that is not uh, very useful or is not relevant during the battle, like the serial number of the Pokemon in the Pokemon Index, the generation the Pokemon was released, etc. And of course, since the, the exact mechanics during the battle is concealed, it's not released publicly, so maybe they do have effect uh, on the battle, but currently, to simplify the discussion, we just drop these columns off the table. After dropping these attributes off the table, we then transform uh, as previously what we did in previous question. We transform the attribute type, and then we can get an get an overview of the distribution of the six base statistics, which is attack, defense, speed, special attack, special defense, and health point, abbreviated as HP. For so we just take an overview of these six base statistics over the 18 type of Pokemon, so we can see the distribution. Uh, so the box plot really is that the uh, basically it indicates the quartile, the median, and the maximum, minimum, and some outlier. Uh, the outlier was represented by the white dots. So okay, so maybe one can say that, or one can refer to these graphs and say, oh, this type of Pokemon, for example, the Dragon type of Pokemon has the highest attack, and for example, for let's say defense, the Steel type of Pokemon has the highest defense in average, or in terms of the maximum. It's the same that it has this highest defense. But can we say that they if one Pokemon has the one type of Pokemon has the highest attack or defense, or either of the attribute, then it can be called the strongest. So what how do we define strongest is quite difficult in this question. We will put this doubt aside, and we continue our discussion, and we will uh, dig into it later. So, as usual, we can use some correlation heat map to see whether the six stats have any correlation. And we can find that the six statistics does not have significant correlation. It's all below 0.5, which is slowly correlated or negligibly correlated. So, okay, that's fine. And we can visualize the the these statistics by the we can in turns if we want to compare not the distribution but compare its median its average of the each type, then we can represent it as a array or as a simple graph. But still, little can be extracted or little can be inferred from this graph, uh, except for telling the rank based on a uh, specific attribute or specific base statistics. So, oh, okay. Oh, so we can uh, there there is uh, uh, an attribute called a total, which indicates the summation of the six base attribute. And sorry, this guess label should be type 1. And we can see that the dragon type and the steel type has the highest total. So can we say that the summation of the six base type represent the strength of of the type of the Pokemon? Maybe, but is the summation of the six statistics an if effective representation of the strength is still in doubt, right? So we keep going. Then maybe you can say that we can calculate how many percentage of each type of Pokemon that there exists a legendary Pokemon in. So we calculate the percentage of Pokemon, how many Pokemon in each type is legendary. So we can see that Flying type and Dragon type uh, have the highest percentage of legendary Pokemon. So you can say, oh, the strongest, meaning that you can collect the most uh, more legendary Pokemons, then it is called strongest. Okay, maybe you can state that, but how can you prove that, right? Some legendary Pokemon is still quite weak in real battle, right? Okay, so maybe you can say, okay, let's see, there's still an attribute called mega evolution. So we can see if the percentage of Pokemon that Pokemons that have Mega Revolution, then the Mega Revolution will increase its defense, attack, etc., and it will have a advantage to win a battle, right? So again, we can still calculate the percentage of Pokemon that have Mega Evolution, but okay, then we can say, okay, again, Dragon and still is quite high, but it does it makes does it make Dragon? You can see Dragon appear one, two, okay, three times, and still appear one, two times. So okay, so you say, oh, by these three uh statistics or a chart, and then we concluded that the dragon is the strongest because it excels in all three aspects of in terms of the in terms of finding out the strongest. But is that the case? So we we review how the Pokemon battle was carried out. So Pokemon battle, unlike the animation, it is a round based battle. So every time a Pokemon A attack Pokemon B, and then Pokemon B attack Pokemon A, and vice versa, until one of the one of the Pokemon's HP becomes zero, then the battle ends, right? So let's say so uh, we try to simulate this process, and then we make some assumption, and based on these assumption we want to find out the strongest Pokemon. So the assumption is that the battle is round based, and this is 1 vs 1 Pokemon battle, and the speed attribute determines which Pokemon strikes first. So in each round, the Pokemon strike only once, okay, against the opponent Pokemon, and incur some HP damage on the opponent's HP. Okay, so when either of the Pokemon's HP goes down to zero, then the battle ends. So, uh, how to calculate the HP damage? So they are uh, officially there is no formula for calculating HP, but in order to quantitatively determine which type of Pokemon is the strongest, we refer to this site, and this site is enthusiastic players. I assume that they magically uh, concluded with these formula for damage. So we can see that the damage is a function that can be described as a lot of factors or attributes. So uh, what what are the attributes that are related to our data set? So we can see the attack of the attacker and the defense of the defender, or these two are included, and the rest of these are not included except for the type. So the type, if you are familiar with Pokemon, we do not have do not we do know that like uh the grass Pokemon are afraid of fire. So the the term afraid of, meaning that the type the damage will be multiplied by a certain uh, factor. So it is quantized by the type. So the only two factors that are related are the A over D, attack over defense, and the type. So okay, attack over defense and the type. So we would like to make a disclaimer that in the following discussion we are going to simplify a lot. For example, for the training, only one Pokemon can be used in a battle, and a Pokemon only use one type of attack that align to its own type, meaning that Pikachu cannot use like Fire Blow or etc. And only one strike is allowed in each round. And average strike hit hit the opponent, and no mega evolution for fairness. So it's quite simplified. Okay, under this simplified model, so a dumb example is that Pikachu and Charmander involves in no is in involved in a battle. Okay, so Pikachu, the Pikachu has a higher speed than Charmander, so Pikachu strike first, and Pikachu will incur some damage to Charmander, and the HP of Charmander will be reduced by the damage. Then Charmander attack, and Charmander will incur some damage on Pikachu's HP, and iteratively until one either Pikachu will strike or struck down, or Charmander was struck down, and the battle ends. Okay, so to calculate the number strike by each each uh each Pokemon. So the question is, how many strike does Pikachu need to strike down Charmander? So the answer, so we define this as m, the number m. Under our simplification, the number requires equals the HP of Charmander divided by the damage Pikachu incur on Charmander, right? So each time Pikachu, like, say, incur 5 damage to the Charmander's HP, and the Charmander HP is 100, so Pikachu will need at least 20, right? 20 times of the attack to strike down Charmander. Okay, so how to decide who will win? So is easily, if the number of strike required by Pikachu to strike down Charmander is less than the number of requires for Charmander to strike on Pikachu, then Pikachu will strike down Charmander early and will win the battle. Alright. Then we defined strongest in terms of the Pokemon that can win the most against all the remaining Pokemon, right? So we are going to determine which type of Pokemon is the strongest. So we first, again, make some assumptions. We only consider battle different between different type of Pokemon. So uh, uh, if you are electric type of Pokemon, you are not going to fight the electric because it doesn't have any meaning in terms of finding out the strongest type if you battle within your type, right? And the second assumption is that we represent all the what the fuck, all the Pokemon of the same type by the average of their base statistics. Okay. Then the third assumption is that the defense is used against attack, and the special defense is used against special attack. And in calculating the damage, we have the variable, which is A, attack over defense. Then we will use the attack over defense and special attack over special defense. Use the sum of it to as the input of the damage function. Then, okay, so these can all be quantized, and for the remaining factors in these formula, we will use the same numeric numbers that is introduced in this website for fairness. Although it is again, we want to say that it is a very simplified model, so we just want to have an overview of who is the best. So this is the way is how we compromise in calculating the damage. Okay, so the procedure as described in the following. So we first calculate the damage matrix for attacker to the defender. okay, using the two attributes. Then we calculate the number of strike required for I to strike down J, which is the ceiling of the HP of the defender, divided by the damage the attacker incur on the defender. Then we calculate the number of wins for each type of Pokemon. So again, how do we define win? Is that the number of strike required is less than the number of strike required by the opponent. Okay, so you can say that, okay, there may be a scenario that we require an equal number of strike to strike on one another. How can we decide who wins? Then the the speed attribute will take effect because the speed attribute will determine who strike first. So if you we and Pikachu and Charmander both require 10 times to strike down each other, but Pikachu strike first, then Charmander will be struck down first, right? So we will take speed as the tiebreaker. Okay, lastly, there are some consideration of representation of the type of Pokemon in the simplified model. We use the average of these base statistics, but in real life, most of the player or video player will choose the strongest Pokemon. For example, if Pikachu is the strongest among the electric type Pokemon, then one player may choose all Pikachu team in to use all Pikachu in his team. But this approach may be more suitable for real life gaming environment. But in a game, we want to say that this is a very simplified estimation, so we just use the average in these analysis. So, okay, let's calculate. So the remaining part is just some quite simple coding. So calculate the first we calculate the average by using the mean function, and we reindex the data frame again according to the order of the effectiveness of a NumPy array. What is effectiveness? So we can use we can refer to this website. This. So the website will tell you if the what is the type fact, what is the number of type in all combination of attacker and defended type. So this is a matrix, then we just encode it as a NumPy matrix, and do the three steps described here. Calculate the damage, and calculate the number of strike required, and if there is okay, the tricky part is that in this graph you can see that some Pokemon, for example, electrics will never cause any damage to grow. I'm not sure what's the abbreviation. So, so under our model, electric will never win the type grow, right? So the number of strike may become so the how to say the damage incurred will become zero, right? So we will we will face the problem of divided by zero. So we just assign in that case, if damage is zero, So meaning that the attacker can incur no harm to the defender, then we just assign a very large number. So let's say 10,000 times in order to strike that down the opponent. So okay, it's only the tricky part is here. Okay, then we calculate the wins. So if there is a tie, then we will use the speed as a tiebreaker. And lastly, we calculate the wins for each type. And we want to verify whether the formula or whether the calculation is correct. Then we sum up all the wins. It equals to 153. So if um, you use the combination, you can find out that 163 equals to C combination equals 18 choose 2. So there are 18 types of Pokemon, and we choose 2 type to battle against each other. They are basically they are exactly the number what we expected. So the calculation was correct, and we want to find out the maximum wins by the Pokemon, which is 14 times. It was quite impressive because there are only 18 types of Pokemon, and we are not going to fight ourselves the same type against each other. So meaning that uh, it only loses 3 times, right? So which type is the strongest? So by this definition, by this simplification, by this assumption, the best type of Pokemon is the Dragon type, which quite coincidentally align with what we have observed by just looking at some very coarse attribute like the percentage of mega evolution or the percentage of legendary Pokemon or just sum up all the base attributes. So, what can we learn from this? Maybe just you don't don't have to calculate all these routine not routine, some trivial or weird model or simplification, or you can just follow your instinct by looking at some really cool maps, or you can say that the question itself is not it's not explicit enough to because it does not, like in machine learning we clearly define the objective function. It only means what is strongest. So in this case, or maybe it is the coarseness of this question that lead to the alignment of the basic analysis and the more complicated analysis. That's it.